Sometimes we want to add responsibilities to individual objects, not to an entire class. A graphical user interface toolkit, for example, should let you add properties like borders, behaviors, like scrolling, to any user interface component. In this example, we have a text view that is decorated with an horizontal and vertical scroll bar plus a border decorator that produces an end result presented here. One way to add responsibilities is with inheritance. Inheriting a border from another class puts a border around every subclass instance. This is inflexible, however, because the choice of border is made statically. A client can't control how and when to decorate the component with a border. A more flexible approach is to include the component in another object that adds the border. The enclosing object is called a decorator. The decorator conforms to a specific interface and it decorates the initial object so that its presence is transparent to everyone that is using the first component initially. The decorator forwards requests to the component and may perform additional actions, such as drawing a border, before or after forwarding. Transparency lets you nest all the decorators that you want in a recursive way, thereby allowing an unlimited number of added responsibilities. So, basically, a decorator attaches additional responsibilities to an object dynamically and provide a flexible alternative to subclassing for extending functionality. Use the decorator when you want to add responsibilities to individual objects dynamically and transparently, that is, without affecting other objects, for responsibilities that can be withdrawn, and when extension by subclassing is impractical. Sometimes a larger number of independent extensions are possible and would produce an explosion of subclasses to support every combination, or a class definition may be hidden or otherwise unavailable for subclassing. The decorator pattern has at least two key benefits and two liabilities. More flexibility than static inheritance, the decorator pattern provides a more flexible way to add responsibilities to objects that can be had with static and multiple inheritance. It avoids feature-laden classes high up in the hierarchy. So the decorator offers a pay-as-you-go approach to adding responsibilities. Instead of trying to support all foreseeable features in a complex, customizable class, you can define a simple class and add functionality incrementally with decorator object. A decorator and its component aren't identical, so a decorator acts as a transparent enclosure, but from an object identity point of view, a decorated component is not identical to the component itself. Hence, you shouldn't rely on object identity when you use decorator. And finally, you might become with a code that has lots of little objects. A design that uses decorator often results in systems composed of lots of little objects that all look alike. The objects differ only in the way they are interconnected, not in their class or in the value of their variables. Although these systems are easy to customize by those who understand them, they can be hard to learn and debug. Uses that are known of decorators include decorators to add graphical embellishments to widgets, also known as wrappers. Streams, on the other hand, are fundamental abstraction in most I/O facilities. A stream can provide an interface for converting objects into a sequence of bytes or characters. A decorator pattern gives us an elegant way to address these responsibilities to streams, and they are not visual.